Hey guys, so welcome to the first video for finance. So now we're just gonna use logs to find what is it, to find n, which is the number of years the investment has been. Yeah, number of years, right? Your investment is going to be or should be or could be. So like with logs, usually you have um when you have y equals to b to the power of x, you can just say x, which is your exponent, is equals to log b, which is the base, and then you have y, right? Cool. So when we come this side, right, you have this, ne? One person can actually say, which is what I'm gonna do is wrong, don't do it. Just showing you a possible mistake one could commit. It's saying that n is going to be log, right? And then you have p into 1 plus I, right? And then here you have a, right? This is wrong, right? You can't do that, né? So but then I'll just give you a chance. Do you think you can tell me why that is wrong, né? So if okay, here is why it's wrong, né? You look at this, né? The exponent x, it has the base b, right? So but then p has an exponent of 1, not n, right? So we can't include it here. So what will actually happen for this, right? Because p is not included there, it's not raised to power of n, right? We will just divide by it, and then you have a divided by p equals to 1 plus I, right, to the power of n. And then because now n, which is an exponent with the base of 1 plus I for interest, right, is equal to this whole thing. So the now when we do our thing, we'll say therefore we have n equals to log, right, the base of the exponent n. What is the base? The base is 1 plus I, right? 1 plus I, and then we have a divided by p. All right, cool. So now let's go solve a couple of questions to see if you do really understand this. Yeah, cool. So here they say Tembile invest 3.5 into a savings account which offers an interest 7.5 per annum compounded yearly, and after an unknown period, so we don't know how long, his account is worth 4,044, yeah, and we need to calculate how long has it been for that 3,500 to end up at 4,000. First thing first, you can basically start with a equal over p equals to a over p equals to 1 plus I, right? You can start your formula like this, bro. You don't have to start it like this and then divide by p to have something. You can literally start here because it's still part of the formula, né? Then the next thing you do substitution, right? So you have 4,044,969, and then you have your 3,500, and then 1 plus 0.075, right? And then you have your unknown n, right? Of which the next day you will say therefore n is going to be log, right? It's log what? Your base, which is gonna be 1.075, and then you have the big guys, then 4,044,69, right? Your calculator straight away, 1.075 and 4,044,69, 35. Yeah, now when you get the answer, you see that it is 2, right? It's gonna be 2 years. Like this is just a, I mean, it's not a, it is two, bro. You run it off to the nearest five, maybe nearest four decimal places. But yeah, it's still gonna get two. So yeah, the answer is like 2 years. You see, even when you say your 3.5 into 1.075, meant to press one. Yeah, 1.075, right? And then close bracket to the power of 2, we get, you see, bro. Cool. Let's do this one. Mr. and Mrs. Tamini, they want to save money for their son's university fee. They deposit 7,000 into a savings account with a fixed interest rate, okay, of 6.5, right? Per year, compounded annually. How long will it take for the deposit to double in value, right? So we want it to double in value, therefore A will just be 2 times 7,000, right? Which is the deposit, or P, so it's gonna be 14,000. So you go to your formula, A over P equals to man. From here on, you're going to do your substitution and say n equals to okay, before substitution we have log 1 plus I think it's even okay to start like this, honestly. Your percentage 0.065, 14, 7. I'm just gonna write 7,000, which is, yeah. Hey, wait, my bad, this is not 7, this is 2, right? This is 2. I can also do this 1 2 3, yeah, 11, right? This is just gonna be a pure 11 years. This is so here, I don't know what went wrong with me, but it is 2, right? So if I write 2, because 14 divided by 7 is 2, so that was just my error. 14 divided by 2, right? So yeah, that was just my error. Yeah, but everything on the screen is fine. It was just my error on the calculator. Let's see if we have other problems. Okay, we just have one last one. We have one last problem. Okay, so Banele, when Banele was still in high school, he deposited 2,250 into a savings account with an interest of 6.99% per annum, compounded yearly. How long ago did Banele open an account if the balance now is 2.8? Cool. So yeah, we already know that n is going to be log of 1 plus I, right? And then you have A over P, right? So we can just substitute straight away. This is 1 plus 0.0699, and you're gonna have A, which is 288, 2.53 divided by 2250. Let me see, it was compounded yearly, so we are still fine. 1.0699 882.532250, and we're getting 3.67 years, right? Yeah, so you know for sure that this is 3 years, right? 3 full years plus and now I'm gonna say 12 multiplied by 0.67 to find how many. This will be months, right? This will be months. So if I say 12 times 0.67, I am getting 8. I'm just gonna say 8 3 years, 8 months and a couple of days. A couple of days. So this is 8 months. Yeah, this is 8 months. So days, let me see, probably 31 times 0.04, which is like 1 day. So yeah, let's just leave it as is, right? To say it's just 3 years, 8 months. Cool. I think we can leave it here, and we're gonna do some cool stuff in the next video.